On this channel, we provide useful programming information with practical code examples. This time, we will be focusing on JavaScript and IndexedDB. This tutorial provides a step-by-step explanation of JavaScript and IndexedDB, including practical sample code at each step to help deepen your understanding. Enabling subtitles will make the code descriptions easier to understand. IndexedDB is an asynchronous key-value store database built into browsers. It offers features similar to relational databases and allows you to store and search large amounts of structured data on the client side. It is especially useful for offline-capable applications and PWAs, progressive web apps. Operates in an asynchronous and event-driven manner. JavaScript objects can be stored in object stores. Searching by queries or indexes is possible. It has a large storage capacity, hundreds of MB or more, allowing you to store much more data than cookies or local storage. To use IndexedDB, you must first open a database. If it does not exist, it is created automatically. The open method opens the database asynchronously and triggers the following three events. The on success event is triggered when the database opens successfully. Subsequent operations should be performed using request result, which becomes available at this point. The on error event is triggered when the database fails to open. Error logging and error handling should be performed here. On upgrade needed is triggered when the database is newly created or when the specified version is higher than the current version. Creating tables, object stores, and defining the schema should be done at this timing. First, create an object store equivalent to a table within on upgrade needed. Here, the following settings are applied. Create object store is a method for creating a new object store in the database. You can store records in an object store and define how data is managed by specifying key path and other options. This process must be done inside the on upgrade needed event. Set the key path to the ID property, which uniquely identifies each record as a primary key. This allows ID to be used automatically when adding, searching, or updating data. Use the createIndex method to create an index based on the name property for searching. By setting unique false, multiple records with the same name are allowed. Assign processes to be executed upon a successful database connection to the on success event. Within this process, you obtain the database instance and prepare for reading and writing data. This process executes when the IndexedDB database connection completes successfully. Event. Target. Result contains the Open Database Instance, IDB database, object, which is used to start transactions and access object stores. Actual read and write operations such as adding, retrieving, updating, and deleting data are performed using the DB object. At this point, the database is ready, so you can safely start transactions. Here is how to add new data to IndexedDB. Create a transaction with DB transaction and specify the object store to operate on and the mode, in this case, read-write. Add new data using the store.add method. Transactions are committed automatically, but if you want to group multiple operations, you can manage them using transaction end events. Here is how to retrieve specific data using the primary key. Create a read-only transaction with DB transaction. Use store.get ID to retrieve the data corresponding to the specified primary key. On success is called when retrieval is successful, and the result is displayed if available. If there is no result, it is treated as no corresponding data. If you want to search by properties other than the primary key, use the index you created beforehand. Access the pre-created name index using store index name. Index.get value retrieves the first record with the matching value. If multiple records have the same value, you can retrieve all of them with index.get all value. To update existing data, overwrite, use the put method. If a record with a matching primary key exists, it is updated; if not, a new record is added. Put is a convenient method that supports both updating and adding. If data with the same primary key already exists, it will be overwritten. If you want to check for existence before updating, you can use get to confirm beforehand. To delete data corresponding to a specified primary key, use the delete method. Use store delete ID to delete data with a matching primary key. Note that even if the data does not exist, no error will occur and it will be considered a success. Implementing error handling will result in more robust code. To retrieve all records in the object store, use the getAll method. getAll retrieves all records in the specified object store as an array. Even when retrieving large amounts of data at once, it is processed efficiently. The results are stored as an array in request result. Always add error handling so you can deal with failures. Open cursor is a method for sequentially traversing records in an object store or index. It is useful when you want to process data one item at a time instead of retrieving large amounts all at once. By using Open Cursor, you start a cursor and retrieve all records in the object store one by one. Use cursor value to get the data object of the current record. Move the cursor to the next record with cursor continue. When cursor equals null, all records have been traversed. For example, the process of changing the name of a user whose name is Alice to Alicia would look like this. By using IDB key range only, you can target only the records whose key exactly matches old name. This is useful when you want to access a specific value directly. After updating cursor value, calling update will overwrite the corresponding record. By calling cursor continue, you can move the cursor to the next matching record. This allows you to process multiple records that match the same key or condition in sequence. By outputting logs in on error, when a process fails, it becomes easier to investigate causes and troubleshoot during operation. For example, the process of deleting all users whose name is Bob would look like this. With cursor delete, the record at the current cursor position is deleted. Since the result is returned asynchronously, you can check the process in on success. IndexedDB is asynchronous and event-driven. All operations must be handled with on success or on error events. When you want to group multiple processes together, it is convenient to wrap them in a promise. Wrapping functions like open database or add user async with promise makes it possible to handle asynchronous processes intuitively with async await. This avoids callback hell and makes the code more readable. IndexedDB is a very powerful feature when you want to perform advanced data management on the browser side. At first, you may be confused by event-based asynchronous processing, but once you understand the structure, you can perform full-scale data operations on the client side. In particular, keeping the following points in mind will help you use it more smoothly. Perform initial setup with, on upgrade needed. Pay attention to the read, write mode of transactions. Indexes allow efficient searching. Data can be stored as objects, making it highly compatible with JSON. By mastering IndexedDB, data management for PWAs and offline apps becomes much easier. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. Thank you for watching. Subscribe to the channel and check out our new videos.